Hey, this is Mr. Doro. Today we're going to be talking about stoichiometry. In particular, we're going to be talking about reaction stoichiometry, and I want you to be able to explain stoichiometry and use mole ratios in an action line. Reaction stoichiometry is the quantitative study of chemical reactions. Quantitative meaning involving numbers. So really, if we think of it this way, it's like how much of this makes how much of that. We're comparing what we had before to what we can have afterwards and how much we use in the process. One of the greatest things we need to know about stoichiometry is that we have to always start with a properly balanced equation. This is an equation right here, a chemical equation, but it is not balanced, so we need to make sure that we know how to balance equations because that is what we have to follow for stoichiometry. So let's go ahead and balance this equation. I'm going to start with the metals, which is my lithium. I have 3 lithiums on the product side, so I'm going to put a 3 in front right here. And that makes my phosphorus are okay. My bromine, though, I have 3 on the reactant side and I have 2 on the product side, which means I am going to have to change this 3 that I put right here and make this into a 6 and a 3 over here in front of this bromine. And so when I have 6 lithiums on this side, I have to put my 2 right here and a 2 right there to keep the phosphorus happy. Once we have our balanced equation, we can think of stoichiometry just like a recipe. In this recipe for Snickers cookies, which you can feel free to make for me at any time, and look at these cute little mole cookies down here also. But for Snickers cookies, we have a recipe that we have 1 cup of butter and so on and so forth, 2 eggs and vanilla, blah, blah, blah. And this makes 60 cookies. This is what our product is, 60 cookies right up here. Now, if we only want to make 30 cookies, we could figure out from this recipe how we have to adjust it. If we want to make 120 cookies, we could adjust this recipe also. That is a quantitative look at this recipe involving numbers. How much of this makes how much of that? Okay, so now that we have our balanced equation, these coefficients tell us a couple different things in here. What we're going to be talking about in stoichiometry is mole ratios. So we're going to be talking about these being related as moles. And so this would be 6 moles of lithium bromide react with 2 moles of phosphorus to make 2 moles of lithium phosphide and 3 moles of bromine. So these are mole ratios. So just like the recipe that we were looking at before, we need 6 of these, 6 moles of these, to react with 2 moles of these, and we're going to make 2 moles of these and 3 moles of these. We could also think about this as molecules too. This could be 6 molecules if we're on a much smaller level. Remember, moles are 6.02 times 10 to the 23rd molecules. This could be molecules also, and this could be molecules, and this could be molecules. So this is like a recipe. If we double the amount of moles of lithium bromide, if we had 12, then that means that we would double all these other ones. We would need, for 12 moles of lithium bromide, we would need 4 moles of phosphorus to make 4 moles of lithium phosphide and 6 moles of bromine. When we're using stoichiometry, we're going to have to be using action lines again. Don't let the action lines scare you because they're not all that bad. But we're going to welcome back the action lines and we're going to use something called mole ratios. This is the basis of stoichiometry. If we want to find out, if we're given an amount of lithium bromide and we want to find out anything else on any of this chemical reaction here, then we're going to have to use a mole ratio to switch it back and forth. Remember, these coefficients stand for moles. So I'm going to show you an easy one how to do this here. This is how many moles of phosphorus are needed to make 22.6 moles of bromine. So we're going to start our action line with what we know. We know that we have 22.6 moles of bromine. Now bromine is Br2. And so I'm going to write that Br2 in there each time. Start my action line. Remember, on an action line, we always copy down the unit, moles of Br2. Now, since I'm at moles of Br2, I have mole ratios right up here that I can switch from one to another at any time. And so since I want to get to phosphorus, I'm going to put up top here moles of phosphorus. And so where do I get the numbers for this? From the balanced equation. This is where I switch from bromine to phosphorus. So up here in bromine, I've got a 3 in front of that. So I'm going to put, for every 3 moles of bromine, there are 2 moles of phosphorus. Here's where that comes from right here, from the balanced equation. And so when I do this, I put an equal sign here. Remember, we start on our calculator by punching in 22.6 times 2 divided by 3, and we get an answer which I'll calculate right now. And the answer I got was 15.06666, so on and so forth. And so I'm going to look at my number of sig figs that I had to start out with, which was 3 sig figs. These are exact quantities, so I want my answer in 3 sig figs. Here are my 3 sig figs, the 1, 5, and 0. I look at this one, that tells me I have to round it up. My answer is 15.1 moles of P. That's all I have left because, see, moles of bromine cancel each other out. And so there would be my answer, and I put a box around it. Okay, I have a skeleton equation right here, and this is not balanced. So what I'd like you to do is I'd like you to write this on your notes and try to balance it. Go ahead and pause it and try to balance it. Once you get it balanced, then I want you to check out your coefficients right here. These are mole ratios. And so go ahead and pause it right now and balance it. Okay, I've got this one balanced now. And so my mole ratios are 2 C2H6s to 7 O2s to 4 CO2s and 6 H2Os. And so what you need to do now is we need to make an action line. And on the action line, down here on the bottom, we are going to start out with what we're given. It says how many moles of oxygen are needed. That's what I want to know, how many moles of oxygen. And so when we do this, we start out with what we're given, which is 14.2 moles CO2. And then down here we're going to put moles of CO2. And then we go to wherever we want to go now. Now that I'm at moles on the bottom, I can go to moles of anything else using the coefficients in the equation. In this case, I want to go to oxygen. So that's what I'm going to do. I'm going to go to moles of oxygen. This is my mole to mole ratio. And so here is my mole to mole ratio. That's the only time I can go from CO2 to O2 or anything else, is when I can switch is from mole to mole. That's the only way from the balanced equation. So then when I look up here, in front of CO2, I've got a 4. In front of O2, I've got a 7. And so now my moles of CO2 cancel each other out. I'm going to be left over with moles of O2. I'm going to have 3 sig figs, and so we're going to punch that in. Okay, so when I calculated this, I got 24.85. Now, if you're in my honors class, then you are going to call that 24.8 because of 3 sig figs and the rule of rounding 5s. And if you're in the regular chemistry class, then we are going to call that 24.9, rounding up, moles of O2. I want you to pause it now and try this next one. 8.6 moles of C2H6 react. I want to know how many moles of oxygen are needed for that. Okay, so calculating this or setting this up, we're going to have 8.6 moles of C2H6. It's very important that you write the formula each time because then we know when we can switch over. So down here we're going to put moles of C2H6. Up here we're going to put moles of O2. We go up to our balanced equation. There's our C2H6. There's our O2. And so we just copy those down. 2 moles of C2H6 to every 7 moles of O2. And then you do 8.6 times 7 divided by 2 and calculate it. And the answer I got was 30.1. Now I only need 2 sig figs because I started out with 2 sig figs. So I'm going to put 30 point, or you could put 3.0 times 10 to the first, and that is going to be moles of O2. Very important that you specify what those are. Cancel out the moles of C2H6. Now it's time for you to try it. I want you to predict the products of this. Remember, we did that by determining the reaction type, and I want you to balance it. Make sure you're checking the charges first, and then you balance it. I want you to answer these 3 questions. They're all mole to mole, so they're all one-step action lines, and it's something that you should be able to do. All right, have a good night. Bye-bye.